Section 1.3, Graphing. So in this section, we will be looking at graphing equations. And graphing is very important because it helps to communicate information of data that we have collected and the relationship between two variables. And so there's many ways to graph, and in this lesson today, we'll focus on only two methods. Okay, so let's look at some definitions first. A graph is a visual representation of a relationship between two variables x and y. A graph consists of two axes called the x-axis, which is the horizontal line, and the y-axis, which is a vertical line. These axes correspond to the variables we are relating. The point where the two axes intersect is called the origin. So for example, this line here is called your y-axis, and this horizontal line is called your x-axis. And right at the center where they meet, this point here is called the origin. Okay, so the first method we're going to look at is called point plotting. And so basically here, you want to pick some numbers for x. So I always recommend that you pick some negative numbers. So I'm going to pick -2, -1, 0, 1, and 2. And then what we're going to do is we're going to substitute it into the equation so that we can find y. Okay, so here we have y equals x minus 1. And our first point is -2. So anywhere you see an x, we're going to replace with a -2. So -2 minus 1 is -3. So now that we have an x and a y, we create an ordered pair. So we list the x first, followed by the y. So now we're going to substitute a -1 for x. So that's going to give me a -2. So my ordered pair is -1, -2. And we do the same for the rest of the values. So x is 0 minus 1, and that's going to give us a -1. And we try x equals 1. So that's going to give me a 0. So my ordered pair is 1, 0. And the last one is when x is 2. 2 minus 1 is 1. Now that you have your ordered pairs, then we can plot those on the xy coordinate plane. And so we're going to have the first one is -2 and -3. So to the left are your negative numbers, and going down is your negative numbers. To the right is positive, and going up is positive. So -2 would be here, and then we go down 3, 1, 2, 3. That would be my first point. -1 and -2. 0 and -1. 1 and 0. And 2 and 1. Since we were able to choose any x that we wanted, then we would connect our points, and we can extend the line using an arrow at the end to represent that this line will go on forever to infinity. Okay, let's look at example number letter B. So again, you can choose any values you want for x. Again, I recommend some negative and some positive. And so here we have y equals x plus 1. So anywhere that you see an x, we're going to substitute it with those values. So here I'm going to substitute a -2 in for my x, and that gives me a -1. So now for x, we're going to substitute a -1. So that's going to give me a 0. And for x, I'm going to substitute a 0. So that's going to give me a 1. And I'm going to substitute a 1. So 1 plus 1 is 2. And last, I'm going to substitute 2 for x, which would give me a 3. Okay, so now we're ready to plot the points. So we have -2 and -1, -1 and 0, 0 and 1, 1 and 2, 2 and 3. So we go 1, 2, and up 3. And now we can connect our points with the line. So if we look at these two examples, what is the difference between the first graph and the second graph, and what do you think caused this difference? Well, if we look at the graph here, this looks a little bit lower than this one. This one looks higher. And if we look at the equations, the only difference is the -1 and the +1. So if we were looking at the origin here, you can see that this point moved up 1. If we look at this side, you can see that this point moved down 1. So the difference here is going to be that we're adding a 1 for the second equation and we're subtracting a 1 in the first equation, causing the graphs to move up or down. Okay, so let's look at example number 2. So same idea, we pick some points for x and some for y. And so the equation here is y equals x squared plus 2. I'm going to substitute the -2. So -2 squared is 4, plus 2 is 6. And let's plug in -1. -1 squared is 1, plus 2 is going to give me 3. And let's plug in 0. 0 squared is 0, so 0 plus 2 is 2. And if I plug in a 1, 1 squared is 1, plus 2 is 3. And the last one, we'll plug in a +2. 2 squared is 4, plus 2 is 6. So we can plot these points, -2, and then go up 6. 1, 2, 3, 4, 5, 6. -1, go up 3. 1, 2, 3. 0 and 2. 1 and 3. And 2 and 6. Connect our points. Okay, so we can see that our graph is a parabola. My order pairs here were -2, 6, -1, 3, 0, 2, 1, 3, and 2, 6. Okay, so let's look at letter B. Same idea, pick some points. And let's figure out what the y's are. So y equals x squared minus 2. If we substitute a -2, we get -2 squared is 4, minus 2 is 2. Substitute a -1. -1 squared is +1, minus 2 is -1. Substitute a 0. 0 minus 2 is -2. And substitute a 1. 1 squared is 1 minus 2 is negative 1. And last, substitute a positive 2. 2 squared is 4 minus 2 is 2. So my order pair is negative 2 and 2, negative 1 and 1, 0 and negative 2, and 1 and negative 1, 2 and 2. So negative 2 and 2, negative 1 and 1, 0 and negative 2, 1 and negative 1, and 2 and 2. This point here should be negative 1 and negative 1. So this should be here. So my parabola is going to look like this. Okay. So if we compare both graphs, it's asking for the difference between the first and the second. So if we compare it looking at the origin here, you can see that the graph moved up 2 places. And if the origin is here, the graph moved down 2 places. In the equation, you can see we're adding a plus 2 and we're subtracting a negative 2. So the difference between the first and the second is that one graph shifted down 2 units, that was graph B, and graph A shifted 2 units up from the origin. And that was caused by subtracting or adding a plus 2. Okay, let's look at 2 more examples here. So y is equal to 4. Again, you pick any numbers you like. So in this example, we have y equals 4, but we don't have an x where we can plug in these numbers. So no matter what the x is, it's always going to be, your y is always going to be y equals 4. So when x is negative 2, y is 4. When x is negative 1, y is 4, and so on. And the reason is there's no x for us to plug in for our values. So my order pair is negative 2 and 4, negative 1 and 4, 0, 4, 1 and 4, and 2 and 4. So if we plot this points, then we get this horizontal line at y equals 4. Okay, so this is a horizontal line. So on this side, they're telling you here that x is always going to be equal to 3. So we're just going to let x equals 3. And so here we can pick any number that we want for the y's. So my order pairs would be these. So 3 and negative 1, 3 and negative 2, 3 and 0, 3 and 1, 3 and 2. So if I connect my points, this is going to be a vertical line that passes through the point x equals 3. Okay, so method number 2, graphing using x and y intercepts. A x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis, and a y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. A 0 of a graph is the x-coordinate of a point where the graph intersects the x-axis. So notice that definition 1 and 3 are exactly the same thing. So in other words, x-intercept is another name for 0. So it says identify the x and y intercepts for each of the graphs below and the zeros. So here you have this line. So let's look at the x-intercept first. So the x-intercept is the x-coordinate of a point where the graph intersects the x-axis. So here's your x-axis, this line right here. So you can see that your graph is intersecting here. So that point here is 2, 0. So my x-coordinate is going to be a 2. So my x-intercept here is x equals 2. The y-intercept is where the line intersects the y-axis. And so that's going to be this point here. So this is your y-axis. So this point is 0, -2. So your y-coordinate is going to be that y value here. So we can say that y is equal to -2. And then the 0, well, that's the same as the x-intercept. So that's still going to be at x equals 2. Let's look at this example. So here we can see that we have an x-intercept here and we have an x-intercept here. And so my x-intercepts are going to be at x equals 1 and x equals -3. So you can write it like this, or you can write it out as x equals 1 and x equals -3. The y-intercept is up here. Notice that's where it crosses the y-axis. And so this point here is 0, 3. So my y-intercept is y equals 3. This point was 1, 0. And this point was -3, 0. So my zeros are the same as my x-intercepts. So that's going to be x equals 1 and x equals -3. So again, here we have this point. So that's where it crosses the x-axis, but notice it also crosses the y-axis. So at x equals 0, that's my y-intercept. And at y equals 0, that's going to be my y-intercept. So my 0 is the same as the x-intercept at x equals 0. So here, notice that the graph never crosses the x-axis. So we say that there's no x-intercept. And for the y-intercept, it crosses at this point, which is 0, 2. So this would be y equals 2. So my zeros is no x-intercept. So in summary, for all x-intercepts in example 4, what was the value of the y-coordinate? So if we look at the x-intercepts, the value of the y-coordinate is 0 here. And notice for these two, the value of the y-coordinate is 0 and 0. And so the value of the y-coordinate is always equal to 0. If we look at the y-intercepts, the value of the x-coordinate is a 0 here and a 0 here. So the value of x in the y-intercepts is always going to be 0. So for the x-intercept, the y-coordinate is always 0, and the y-intercept is always going to be, the x-coordinate would be 0. So why is that important? Well, it can help us find the x and y-intercepts. If we don't have the graph, we can find it algebraically. So if you want to find the x-intercept, then just remember that we let y equals 0 and solve for x. So in our equation, y equals 3x minus 2, we let y equals 0 and solve for x. So I'm going to add 2 on both sides and divide by 3. So x is equal to 2/3. So my x-intercept is 2/3 and 0. And then for the y-intercept, we're going to pick let x equal 0 and solve for y. So in the equation, we let x equal 0. And so y is equal to -2. So my point is 0, -2. Okay, so if we plot these points, we have 0, -2, which is right here. 2/3, which is around right here, and 0. Draw our line. So when it's a line, we just need 2 points. But if this wasn't a line, then you would need additional points. Later on, you're going to figure out just by looking at this if you have a line or something else. Okay, so let's look at this example. Y equals negative x plus 3. We're going to find the x-intercept. So we get let y equals 0 and solve for x. So 0 for y. So I'm going to subtract 3 and divide by negative 1. So x is equal to 3. So my x-intercept is at 3, 0. So for the y-intercept, we let x equal 0 and solve for y. So y is equal to negative x plus 3. We're going to let x equal 0. So y is equal to 0 plus 3, which is 3. Plot the points. And so we connect our points. And that's going to be our line.